our fingerprints are unique to us. And so to leave a fingerprint at a crime scene is an important piece of forensic evidence. We're going to look today at a couple of chemical means of finding those fingerprints. The skin surface contains several chemicals that are going to be useful. First of all, skin is greasy, so there's a layer of grease or fat on the skin. Secondly, skin is sweaty. Sweat contains sodium chloride, which is an ionic salt, and we'll be able to test for that. And third, skin might contain some pieces of protein that will be shed when the skin surface comes into contact with another surface. Let's do some simple spot tests. This is a solution of silver nitrate. We might remember from class that all nitrates are soluble in water. And so the nitrate carries the silver ions into solution. As a solution, it's just colorless. I'm going to put a thumbprint on that piece of paper. And then using tongs, because I now, as a forensic investigator, don't want to contaminate this scene by using my own fingerprints, I'm going to wet the surface of that paper with the silver nitrate solution. You could do this by spraying it on, or just in this case, wetting the surface. I'm going to let that dry, but what I'm also going to do is I'm going to take it out into the sunlight, because the reaction that we're about to see is promoted by ultraviolet light. What we're about to see is that nitrate that is soluble is going to be converted into chloride. Silver chloride is insoluble, so it should leave a trace of where my fingerprints were. I've brought my sample outside. It's still wet, but as soon as the sunlight hit it, you started to be able to see small little grains of color, like a photographic print, start to develop where my fingerprint was. I'll let this dry. This is what the silver chloride fingerprint looks like after it's been allowed to dry. We can also put this under ultraviolet light, which will enhance the areas where the silver chloride has deposited. So let's think about what exactly is going on. I have silver nitrate. All nitrates are soluble. So this nitrate is putting that silver into aqueous solution. Sodium chloride. That's the salt that's in my fingerprint. It's on the surface of my skin. All sodium salts are soluble in water. So sodium chloride dissolves very easily in water. When these two react together, we're going to do a double replacement or double displacement reaction, where the front of this combines with the tail of that, and the tail of this combines with the front of that. And we're going to make silver chloride and sodium nitrate. Now we know all sodium salts are soluble, all nitrates are soluble, so sodium nitrate is guaranteed to stay in solution. Most chlorides are soluble in water, but silver chloride is not. So this precipitates, it falls out of solution and is a solid. If we blow all of that up and convert it into what's called the complete ionic equation, because ionic material, when they dissolve in water, they split apart into their component ions, which means I'm going to put silver ions and nitrate ions into solution. And sodium chloride splits apart to make sodium ions and chloride ions. And sodium nitrate in solution splits apart to be sodiums and nitrates. But silver chloride is not in solution, it's a solid, which means you can take out your pen and say that and this are not part of the answer. Silver ions in the reagent meet with chloride ions in the salt that's on the surface of my skin, and they make silver chloride, which is a precipitate. And then ultraviolet light lets us deposit little silver particles out of that so that we see an almost photographic effect. I've put some silver nitrate solution in this test tube, and I'm just going to drop in some tap water. Tap water has enough dissolved chloride in it to immediately cause silver chloride to precipitate. This is iodine. Iodine is a non-metal and it's a solid. In its solid form, it has a little sheen to it. It looks like almost metallic. It's just a gray-ish solid. But iodine does something that a lot of other chemicals don't do. It turns directly from the solid phase into the gas phase. Does not go through the liquid phase in the middle. The process is called sublimation, and I've put the granules of iodine into this beaker and I've covered the lid, and I'm just going to let it warm up a little bit to room temperature and see what happens. In fact, I might warm it up just a little bit. So I've just put the beaker with my crystals of iodine onto just a warm plate. And you can see already that something purple is happening. The solid is vaporizing, it's turning into a gas, and it's not passing through the liquid phase. It's just turning directly into a gas. If I put a white piece of paper behind, you can see that this beaker is just filling with purple vapor. This is iodine vapor. It's a physical change. It's called sublimation. We normally see solids melt, become liquids, and then boil to become gases, but iodine sublimes and goes directly from being a solid to being a gas. I'm going to take a piece of paper, put a thumbprint on that paper, and then use some tongs and put my paper in with the iodine vapor. You can see immediately that has developed a thumbprint. Let's go take that out. Here's what that thumbprint on paper looks like after just a few seconds. You can see all of the swirls in there. What has happened is that iodine, because it's a non-polar molecule, has attached to the grease in my fingerprints, which is also non-polar. And then iodine has oxidized the grease from my fingerprints, turning the purple to a reddish brown color.